Hello, all of you, good evening. Welcome to our channel Acharya Mathematics. I trust you are well, staying safe and healthy. Once again, welcome to our channel Acharya Mathematics. In today's class, we discuss continuation of the lecture 1. In case you have not seen my earlier video, please go through it. You will get my link in description box. Before going to start today's lecture, let us revise what we have studied in previous class. In previous class, we have observed that definition of matrix, order of a matrix, and types of matrices. Now observe that one more important concept. When we say that two matrices are equal, here we roughly speak that one matrix is the duplicate of the other. In such case, we say that they are equal matrices. Duplicate means one matrix is the photostat of other. Okay, got it here. See here, I take one example here. 2, 3, 5, 6 is a matrix. Okay, this is a matrix of order 2 cross 2. Suppose if I take suppose that here 2, 3, 5, 6, I have considered the matrix 2, 3, 5, 6. If it's get photostat, what we get here? We get again same matrix like 2, 3, 5, 6. Is it right? So here what I am going to say that these two matrices are said to be equal. With the understanding, this, can you define equal matrices? Can you define equal matrices? Here, see, definition very simple. Two matrices are said to be equal. Two matrices are said to be equal if first condition is their orders are same. I mean that if it is a 2 cross 2 matrix, it should be 2 cross 2 matrix. If it is m cross n matrix, this should also m cross n matrix. The second condition is corresponding elements are same. Corresponding elements, so this is the position of first row, first column. In this matrix also, first row, first column matrix should be same. So here, this is the definition of equality of matrices. So here, two matrices are said to be equal if their orders are same and corresponding elements are same. Okay, if A is a matrix and B is a matrix, if they are equal, then we write it as A equals B. So this is symbolically we represent two equal matrices. Okay, so in general, let us see here one example. I take one example here. Let 2, 3, 5, 6, 7, 8. It is a matrix. It is a matrix of, what is the order here? Here we have 3 rows and 2 columns. This is a matrix of order 3 cross 2. And I take one more matrix of the order 3 cross 2. Here I take it as elements A, B, C, D, E, F. Suppose these two matrices are equal, then the corresponding element should be same. I mean that here A equals 2, B equals 3. C equals 5, D equals 6, E equals 7, F is equal to 8. Okay. Now here we define in general. So how do we define in general? Let A is a matrix. We write it as in compact form like this. Aij M cross N. And B is a one more matrix. I write it a compact form, that is N M cross N. I take it as R cross S. Okay. Here these two matrices are said to be equal. The first condition is order should be same. Here A is a matrix, has M rows, N columns. Matrix B has R rows, S columns. I mean that here first condition should be M equals R. Yes or no? And number of columns is same. N is equal to S. Okay. Next here, the corresponding elements are same. Corresponding elements are same means Aij equals Bij for all Ij. Okay. So here for all Ij. So the Aij is equal to Bij. So this is the general definition for two matrices A and B. So this is for all I and J. Okay. So this is the definition of equality of two matrices. Now let us, so here we have discussed introduction to exercise 3.1. So here theoretical part is over. Next let us we move to the exercise 3.1. Let us we discuss exercise 3.1. See the first exercise is exercise 3.1. The first question is in the matrix A equals 2, 5, 19 minus 7, 35 minus 2, 5 by 2, 12, root 3, 1 minus 5, 17 is given. Okay. So here there are three sub questions are there. Write the order of the matrix. Write the number of elements. Write the elements A13, A21, A33, A24, A23. Is it right? So here order of the matrix means we have to find the number of rows and number of columns. Here how many rows are there? This is row 1, row 2, row 3. That is for the answer for first question is 3 rows are there and 4 column 1, column 2, column 3, column 4. 3 cross 4. Okay. Next for second question, the number of elements. The number of elements means actually we have to count the number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is one method. After counting practically we get 12 elements. Or here we observe that number of elements is equal to number of rows into number of columns. Yes or no? So here simply we say that number of elements is equal to 3 into 4, that is equal to 12. Okay. Next, write the elements of A13, A21, A33, A24, so A23. So A13 means here first suffix indicates the rows and second suffix indicates the column. Means we have to find out an element of first row, third column. This is equal to 19. Is it right? Very simple. Next, A21. So A21 is second row, first column. That is 35. Next, A33. A33 is third row, third column, third column, that is equal to minus 5. Next, A24. A24 equals second row, fourth column, 12. Next one is A23. A23 is second row, third column, that is equal to 5 by 2. Okay. This is the first question. Let us see question number 2. The question number 2 is, if a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? First, you read out the question. If a matrix has 24 elements or 24 entries, what are the possible orders? Here, just you observe that the number of elements is equal to product of the number of rows and number of columns. Is it right? So here, you have to observe that what product of two numbers gives 24. So here there are possibilities like this. 1 into 24 gives 24. Is it right? It means that in the case of one row, 24 columns, we get 24 elements. Next, 2 into 12 also gives 24. It means that in a matrix of 2 rows and 12 columns also we get 24 elements. Okay. So similarly here 3 into 8 gives 24. Next 4 into 6 gives 24. Next 6 into 4 gives 24. Next 8 into 3 gives 24. Next 12 into 2 gives 24. Next 24 into 1 gives 24. Means in all these cases of the product of two numbers gives 24. Therefore the possible orders 1, 24. Okay. Next second possibility is 2, 12. Next possibility is 3, 8. 4, 6. 6, 4. 8, 3. 12, 2. 24, 1. These are the possible orders having 24 elements. The first question is over. Next, again, there is one more question. What if it has 13 elements? If it has, since the matrix has 13 elements, means the 13 can be written as only in two cases. 1 into 13 is equal to 13, or 13 into 1 gives 13. Means the possible orders, that is 1, 13 or 13, 1. This is the answer for question number 2. I hope all of you got it. Yes or no? If you have any doubt, you can chat with me. Okay. Okay. Next, question number 3. So, question number 3. If a matrix has 18 elements, what are the possible orders it can have? What if it has 5 elements? Again, question number 3, exercise 3.1, question number 3. So, is exactly similar to previous question. Okay, since the matrix has 18 elements, we find the product of two numbers such that it gives 18. That's all. That is first possibility. 1 into 18 gives 18. Next 2 into 9 gives 18. 3 6 18. Next 6 3 18. Next 8 3. Next 9 2 18. 18 into 1 is 18. Okay. Here the possible orders are 1, 18. 1, 18. 2, 9. 3, 6. 6, 3. 6, 3. 9, 2. 18, 1. This is the answer. Here again one more question. What if it has 5 elements? Okay. So 5 elements. Since the matrix has 5 elements, we find two numbers such that their product gives 5. Only two possibilities. 1 into 5 equals 5. 5 into 1 is equal to 5. Therefore, only the possible orders are 1 comma 5 and 5 comma 1. This is question number 3. Okay. I hope all of you got yes or no. So next question number 4. Construct a 2 cross 2 matrix A equals Aij whose elements are given by. There are 3 sub questions are there. The question is very important in the point of examination view. So previous also may be asked for 1 mark question. Question number 2 and question number 3. Okay. Here question number 4. Construct a 2 cross 2 matrix A equals Aij whose elements are given. First we discuss question number 1. So here 2 cross 2 matrix. First you write the general elements. 2 cross 2 means it has 4 elements. What 2 rows, 2 columns. A11, A11, A12, A21, A22. Okay, this is 2 cross 2 matrix. Here for each to determine the elements, we use this one. Here given that general element is given Aij equals I plus j whole square divided by 2. What it here? Aij defined as I plus j whole square by 2. To get A11, what to do here? You just replace I by 1 and j also by 1, because in place of I we have 1, in place of j is also 1. Next, after simplifying, we get the answer. 1 plus 1 is 2, 2 square is 4, 4 by 2, that is equal to 2. So it means that the first element A11 is 2. Got it here? Next, you take A12, A12. A12, again we have to use the given definition, the I plus j whole square by 2. Here I is 1, because in place of I we have 1, in place of j here we have 2. You write it as 1 plus 2 whole square divided by 2. 1 plus 2, 3. 3 square is 9. 9 by 2. Yes or no? Next one is A21. A21. Here I is 2, j is 1. That is I here it is defined as I plus j whole square, means I is 2, j is 1 whole square divided by 2. 2 plus 1, 3. 3 square is 9. 9 by 2. Okay. Next A22. A22. Here I is 2. J is also 2. You substitute here. In place of I 2. J in place of j also 2. Whole square divided by 2. 2 plus 2, 4. 4 square is 16. 16 by 2 is 8. So thus we have got it here, 4 elements. Next you have to replace all A11, A12, A21, A22 by all these elements. Therefore, A is equal to, A equals 2, 9 by 2. Next A21, A21 is 9 by 2. A22 is 8. So this is the way required the matrix. Okay. Next, we move to the question number, same exercise 3.1, question number 4. First sub question is over. Next we move on to the question sub question 2. Here this is general element defined as I by j. Okay, I by j, I upon j. Again we need 2 cross 2 matrix. Okay, so here general element Aij given as I upon j. We have to find 2 cross 2 matrix. First to write general elements A11, A12, A21, A22. Okay. Next, you find y one by one. So a11 equals, if the question is very easy, if you want we can write directly. A11 means 1 upon 1, it gives 1. Or you got it? Here second, I is 1, j is 2, 1 upon 2. So this is 1 by 2. 2 by 1, so this I is 2, j is 1, that is 2 upon 1. 2 upon 1 is 2. Next, A22. I is 1, 2, J is 2. 2 upon 2, that is 1. Okay, got it here? Okay. Next, we move to the question number 3. Here, question number 3 means sub-questions. Sub-question 3. Aij equals I plus 2j whole square divided by 2. Aij equals I plus 2j whole square. I plus 2j whole square divided by 2. Again here we have to find 2 cross 2 matrix with this definition. So A equals, you write A11, A12, A21, A22. This is 2 cross 2 matrix. Okay. Next, let us we find here each elements, that is A11. A11 defined as, here I is 1, j is also 1. Substitute I equals 1, j equals 1. 1 into 2 is 2. Yes or no? Whole square divided by 2. Next, we make it simplification. 1 plus 2, 3, 3 square, 9, 9 by 2. Next, A12. A12 equals I is 1, j is 2. 1 plus, when I substitute in place of j equals 2, 2 into 2 is 4. Yes or no? Whole square divided by 2. 1 plus 4, 5. 5 square is 25 by 2. Next, A21. A21 equals, in place of I we have 2. In place of j we have 1. Yes. That is 2 into 1 is 2. Whole square divided by 2. 2 plus 2, 4. 4 square is 16. 16 by 2 is equal to 8. Next, A22. A22 equals I is 2, j is 2. So I plus, so I is 2. Next, j, here j is 2. 2 into 2 is 4. 2 into 2, 4. Whole square divided by 2. 2 plus 4, 6. 6 square is 36 divided by 2. That is equal to 18. So in this way, you have to first find the elements by using given condition or by given definition of general element. Now you have to write the elements. Here A11 is 9 by 2, A12 is 25 by 2, A21 is 8, so this is 18. Okay. Next, here question number 4 is over. Next, we move on to the same exercise. We move to the same exercise, exercise 3.1. Exercise 3.1, question number 5. Exercise 3.1, question number 5. Again, there are two sub questions are there. The question is, construct a 3 by 4 matrix whose elements are given by. We discuss one by one. Okay, the first question number 1. Question number 1, general element is defined as Aij equals half into modulus of minus 3i plus j. This is general element. Next, here first you write general matrix. A equals, here what is the order here? 3 by 4. 3 by 4 means 3 rows and 4 columns. Okay, first you write one row. First row A11, A12, A13, A14. I have taken 4 elements because It has 4 columns. Okay. Next, A21, A22, A23, A24. Next, A31, A32, A33, A34. So this matrix has 3 rows and 4 columns. So this is the general matrix. Next, you have to find each elements by using given definition. That is, you write A11. A11 equals half into, here A is 1, J is 1. You substitute here 1 into minus 3. That is minus 3. So this is modulus plus J is also 1. What we get here? That is minus 3 plus 1 is minus 2. After taking outside the modulus sign, it becomes plus 2. That is 2 by 2 is 1. Got it or not? Next, A11. Next, we find A12. That is half into modulus of I is 1. 1 into minus 3. That is minus 3 plus J is 2. J is 2. So that is equal to half minus 3 plus 2 is minus 1. After taking modulus sign, it become plus 1. Is it right? That is half into 1. It gives 1 by 2. Yes or no? Next, here A13. A13 equals half into modulus of 1 into minus 3 plus J is 3 minus 3 plus 3 0. 0 modulus of 0 is 0 itself. 0 into half is 0. Next, A14 that is equal to 1 by 2 into modulus of 1 into minus 3 is minus 3 plus J is 4. That is equal to 1 by 2 minus 3 plus 4. Minus 3 plus 4 is 1 plus 1. That is equal to 1 by 2. Okay. Next, we come to the A21. So A21 is defined as A21 is half into I is 2, J is 1. 2 into minus 3, that is minus 6 plus J is 1. 1 by 2 into minus 6 plus 1, that is minus 5 of, this is minus 5, modulus of minus 5. Here modulus of minus 5 is plus 5. So this is 5 by 2. Okay. Next, A22. So A22 is 1 by 2 into 1 by 2 modulus of I is 2, J is 2. 2 into minus 3 minus 6 plus 2. Okay. Minus 6 plus 2 is minus 4. After taking outside, it becomes plus 4 only. That is half into 4. That is equal to 2. Next, A23 half into I is 2. That is minus 6 plus J is 3. That is equal to half into minus 6 plus 3 is minus 3. After taking outside, it becomes plus 3. So answer is 3 by 2. Next is A24. A24 is half into modulus of 2 into minus 3 minus 6 plus 4. Okay, that is half into minus 6 plus 4. That is half into minus 6 plus 4 is minus 2. After taking outside of the modulus sign, 2, that is equal to 1. Okay. Next, we find A31. Okay, A31 is equal to 1 by 2 into I is 3 here. 3 into minus 3. 3 into minus 3 is minus 9. 3 into minus 3 is minus 9 plus 1. Okay, so that is equal to, that gives minus 9 plus 1 is minus 8. After taking outside, plus 8 plus 8 by 2 is 4. Okay, next A32 is half into modulus of minus 9 plus 2. Minus 9 plus 2 is minus 7. So that is equal to 7 by 2. Next, A33. A33 equals 1 by 2 into modulus of minus 9 plus 3. Minus 9 plus 3 is minus 6. That is after take outside of the modulus sign plus 3. 6 by 2. That is 3. Next, A34. 1 by 2 into minus 9 plus 4. That is equal to minus 9 plus 4 is minus 5. So it becomes plus 5. 5 by 2. So now I am going to write the matrix A as, that is 1. This is 1. Next, half, 0, half, 5 by 2, 2, 3 by 2, 1, 4, 7 by 2, 3, 5 by 2. So this is the matrix we required. Here sub question 1 is over. Next we move to the sub question 2. That is general element given by 2i minus j. 2i minus j. Again you have to write the matrix 3 rows, 4 columns. A11, A12, A13, A14. Next, A21, A22, A23, A24, A31, A32, A33, A34. So here general element given as 2i minus j. Aij equals 2i minus j. Okay. Next you write down here. You calculate A11. Here this is quite easy. If you want, you can write directly orally. You can write here I is 1, j is 1. 2 into 1 is 2. 2 minus 1 is 1. Next, again first row means here I is always 1. 2 into 1 is 2 minus 2, 0. I hope you understood, yes or no. Next, 1. 1 into 2 is 2. J is 3. 2 minus 3, that is minus 1. Next, here 1 into 2. 2 minus 4, minus 2. Next, A21, here in the second row. Here I is 2. 2 into 2 is 4. J is 1. 4 minus 1, 3. 4 minus 2, 2. 4 minus 3, 1. 4 minus 4, 0. In the third row, I is 3. So what happens here? 3 into 2, 6. 6 minus 1, 5. 6 minus 2. Because why minus 2? J is 2. 6 minus 2, 4. 6 minus 3. Why minus 3? J is 3. 6 minus 3 is 3. 6 minus 4 is 2. So this is the answer. Okay. Next, let us we move to the question number 6. Find the values of x, y and z from the following equations. Okay. So here there are two sub questions are there. Find the values of x, y and z from the following equations. Means here it is the equation on both sides we have matrices are there. Okay, and equal sign is there means they are two equal matrices. So according to definition of equal matrices, two matrices are said to be equal if their orders are same and the corresponding elements are equal or same. Yes or no? So here this is 2 cross 2 matrix. We need to find x, y, z. See here. Here in the left hand side we have x in this position. Means second row first column. Second row first column. Here also again we have to find the second row first column. Okay. Therefore x is equal to 1. You have to write down since by equality of two matrices x is equal to 1. Next we find y. So y is in the first row first column. Yes or no? So here y is equal to 4. Next z. Here you take z here. Z is present in the first row second column. So this is first row second column. Therefore z is equal to 3. Next here, question number sub question 2. X plus y, here again there are two matrices are given, that is both are 2 cross 2 matrices, right? That since they are equal matrices, by definition of equal matrices, x plus y, so here this x plus y is equal to 6. Yes or no? And variables unknowns here, x into y equals x into y is equal to 8 and 5 plus z is equal to 5. Okay, so here one value we can find very easily. Here 5 plus z is equal to 5. Therefore z is equal to 0. Z equals 0. Okay, and next x plus y equals 6, xy equals 8. We have to find values of x and y. Okay, here we can find very easily here x plus y equals 6, xy equals means we have to find two numbers such that their sum is 6, product is 8. Okay, product is 8. Those numbers are 4 and 2. 4 plus 2 gives 6. 4 into 2 gives 8. Is it right? So when x is equal to 4, y must be 2 and z is equal to 0. Yes or no? Here you carefully follow here. Why should I have to take for x as 4? Why not I should take y as 4? You can also take like this also, because here 4 plus 2 gives 6 means 2 plus 4 is also 6. Okay, so therefore one more possibility is there. If x may be 2, then y is equal to 4. Z value doesn't also, that is equal to 0 only. Okay, so here the question is very important. So in this case, in this example, we get two sets of values. When x equals to 4, y equals to z equals 0. When x equals to y equals 4, z equals 0. So this completes question number 6. Next we move to the sub question 3. Again you find the values of x, y, z. So here don't make confuse here. This is we have only one column is there. Only one column. This is column matrix. Okay, how many rows are there? Row number 1, row number 2, row number 3. Okay, so this is 3 rows and 1 column. So here also we have 3 rows and 1 column. Just by definition of equality of matrices, you just equate it. So we get x plus y plus z is equal to 9. Next, equate in the corresponding elements. X plus z is equal to 5. Y plus z is equal to 7. Okay, you call it as 1, 2, 3. You have to solve this equation to get values of x, y, z. So, okay, so here x plus z is equal to 5. Yes or no? and y plus equal to 7. Okay, I am going to substitute, put 3 in 1. What happens here? You write x as it is. Here y plus z is equal to, I replace by 7 equals 9. Therefore, x is equal to 9 minus 7 is equal to 2. Okay, when x equals 2, we can find z here. You put x is equal to 2 in the equation number 2. That is 2 plus z is equal to 5. Therefore, z is equal to 5 minus 2, that is equal to 3. Okay, after getting z is equal to 3, you can put here either equation number 1 or 3. Okay, if you consider equation number 1, you have to substitute x equals to z equals 3. Here, if you consider equation number 3, by just to substitute z is equal to 3. Okay, so you write y as it is here, plus z equals 3 equals 7, or y is equal to 7 minus 3 equals 4. So thus we got the values of x, y, z. Okay, next let us we move to the question number 7. Find the values of a, b, c and d from the equation. Here in the left hand side we have 2 cross 2 matrix, right hand side also 2 cross 2 matrix. Just by equate the corresponding elements. So a minus b is equal to minus 1. Next one is 2a plus c equals 5. You call it as equation number 1, equation number 2. Next 2a minus b equals 0. You call it equation number 3. Next 3c plus d is equal to 13. Here after solving we get the values of a, b, c, d. Okay, so then how do you solve here? A minus b is equal to minus 1. Okay, here 2a minus b equals 0. I am first solving equation 1 and equation 3. Solving 1 and 3. So a minus b is equal to minus 1. 2a minus b equals 0. Here on subtracting, what we get here? Here this become plus, so it get cancels. A minus 2a, a minus 2a is minus a equals minus 1. So therefore a equals 1. We got it one value as a equals 1. Okay, next if you put a is equal to 1 in the equation number 1, what we get here? 1 minus b equals minus 1, or minus b is equal to minus 1 minus 1, minus b is equal to minus 2, or b equals 2. So we got two values a and b. Next we need to find c and d. Okay, c and d. Again you put a is equal to 1 in the equation 2. That is 2 into 1 plus c equals 5. Put a equals 1 in the equation number 2. That is 2 plus c is equal to 5. C is equal to 5 minus 2. That is c is equal to 3. Okay. Next we need a value of d. Okay. You put c is equal to 3 in the equation number 4. 3 into 3 gives 9, plus you write d as it is equals 13. Therefore d is equal to 13 minus 9 equals 4. Therefore d is equal to 4. So thus we solved the way b, c, d. Okay, a is 1, b equals 2, c equals 3, d equals 4. So it completes question number 7. Next here, three more questions are there. They are multiple choice questions. Okay. The question number 8 is A equals Aij m by n is a square matrix if There are four options are given. M is less than n, M is greater than n, M equals n, and D none of these. Just you recall the definition of square matrix. Okay, a matrix is said to be square matrix if it has number of rows equal to number of columns. Yes or no? A matrix is said to be square matrix. Square matrix if it has number of rows are equal to number of columns. So here given matrix Aij M cross N. M indicates that number of rows. N indicates represent number of columns. It becomes square matrix only when M is equal to either M is equal to N or N equals M. It means that value of M and N are equal. Therefore, the answer is here option C is right. Okay, next which of the question number 9, which of the given values of x and y make the following pair of matrices equal? Here two matrices are given, that is I can take an already equality. So for which of the following values of x and y make the following pair of matrices equal? Okay, four options are given, that is like this. Let us find the values of x and y. So here I write here itself. So matrix is matrix 3x plus 7, 5 and y plus 1, 2 minus 3x equals 0, y minus 2, 8, 4. Okay, here first we find the values of x and y. Okay, let us check the answer. First, since the matrices are equal, then the corresponding elements must be same. I am going to equate here 3x plus 7 is equal to 0. Therefore, 3x equals minus 7. X is equal to minus 7 by 3. Okay. Next, I am going to find here one more x is there. You don't make confuse here. Here, when I am going to equate 2 minus 3x is equal to 4, we get minus 3x is equal to 4 minus 2, or minus 3x is equal to 2, or x is equal to minus 2 by 3. So it means that what it gives the answer here, x either may be minus 7 by 3 or x may be either minus 2 by 3. So our definition says that, what says that here, corresponding element two matrices are said to be equal if their orders are same and corresponding elements are same, means value of x and y should be unique. But here we got it here, x is equal to minus 2 by 7 by 3 and minus 2 by 3 means x is not unique. Means it means that x should not having the two values. Therefore, there is no x value satisfying the definition, satisfying this equation. Similarly, y is also not possible to find the value from this equation. So therefore, the option is not possible to find x and y. This is the answer B. Okay, got it. Next, one more question, that is so this is the last question. This is very important question. The number of all possible matrices of order 3 into 3 with each entry 0 or 1 is. Four options are given. Let it be option okay. First, you read out the question and understand here the question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1. Or you got it or not? Here, before going to this question, I make it as one question as introduction to this one. That is, Here, what is given here? Number of all possible matrices of order 3 by 3 with each entry 0. I take it as let us first find the possible matrices of order 2 cross 2. Each entry is either 0 or 1. This is introduction. This is introduction to solve the question number 10. Okay. Here just practically I will solve here this question. First you write the 2 cross 2 matrix possible orders with entry 0 or 1. Okay. First I write 1 0 like this and remaining all the 3 elements as 1 1. Okay. Next I change the position here 0 and I move in the same anticlockwise. This is 1 1 1. Okay. Next I write here 0 is here and write 1 1 here. Okay. Next I write here 0 1 1 1. Do you understand here? So here this is the matrix of 2 cross 2 with entry either 0 or 1. Next I start 2 zeros 0 0. Next I write remaining 1 1. Next I write zeros here 1 1. Next I write zeros here and remaining entries I write 1 1. Next I write here 0 zeros and remaining entries as 1 1. Okay. This these are the 2 cross 2 matrices of a 0 or entries 0 or 1. Next I take 3 zeros here. Okay. 1 0 2 0 3 0. I write here 1. Okay. Next I write here start zeros here 0 0 0 here 1. Next I write 0 from 0 0 0 1. Next 0 0 0 1. Again we can also write this is this type of 2 cross 2 matrix which is 0 or 1. Yes or no? Is any chances to write one more or again to write 2 more or 3 more matrices? Okay. So here next I take a diagonal element 0 0, then it is 1 1. Okay. Next 0 0 1 1. Okay. Next 1 1 1 1. Next 0 0 0. Okay. Have any idea to write many other matrix of 2 cross 2 matrix having 0 or 1? Okay. No, there is no chance to write. How many possibilities there? 1 2 3 4. Okay. 5 6 7 8 9 10 11 12 13 14 15 16. So here there are 16 possibilities to write down 2 cross 2 matrices with entry 0 or 1. Now you come to the conclusion here. 2 cross 2 matrix means A11, A12, A21, A22. Okay. Here there are how many elements are there? There are 4 elements are there. Each element has 2 possibilities, either 0 or 1. Okay. So it means that here 2 to the power of 4 gives 16 possibilities to write down the matrices, different types of matrices with entries 0 or 1. Got it or not? With keeping this in mind, now we can solve the question number 10. So here the number of all possible matrices of order 3 by 3 with each entry 0 or 1 is. So here A is a matrix of order 3 cross 3. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is 3 by 3 matrix. How many elements are there? There are 9 elements are there. So each element has 2 possibilities to write down, either 0 or 1. 2 possibilities. Therefore 2 to the power of 9. Then 2 to the power of 9, after simplifying you will get 512. So this is the answer. Okay, all of you got it here. So it completes exercise 3.1. Okay, thank you for watching. Okay, if you are not subscribed my channel, please subscribe and share your friends. And again watch for next lecture number 3, that is the introduction to exercise 3.2. Okay, thank you.